So we're processing colors now. I got it on the breadboard, the color control system, and I just have it connected to these dip switches. So if you put one of them on, let's put that on, you get a red. That's a pretty nice color. And these control individual bits of the 24 bits going into and getting loaded into the shift registers. So these three top ones are the shift, the parallel in, serial out shift registers, the 74HC165, and there's three of them, and they're connected serially to this white wire, which goes into the neopixel driver. And then, and if I change the colors around, let's try to change this one. Now I got a blue when I put 2 bits on from that one right there in the middle one. So I get a nice blue color on the neopixel, if it could focus. Yes, there it goes. And you keep changing them around. I'm messing with the circuit here, so let's see if we can get another color. Let's see here. The only problem with the dip switches is that they are painful to switch. And let's see if I can get this circuit to stabilize. There. Now I got a nice yellow color going there. All right, so I'm gonna change around the dip switches and add bits here and there. So basically, I just have to have a more precise connection than just a loose, jumper wire getting connected to the neopixel driver. And the clock is basically just sitting there like that. And when I turn the clock off, it stops clocking them in. But when I put it back on, if I could get it back in here, there we go. Then by changing the clock, I keep changing the order in which the bits are being clocked in, so the color just changes based on where the clock is. So there was red, there was blue. If I change it again, it just goes to different colors as long as I eventually get the clock to synchronize. There. Now we got green. So I just have to have the clocks synchronized with the clocks powering the counter. The counter is right here, and basically it counts to 24, and every time it counts to 24, it sends a low pulse through this NAND gate. This is a transistor-based NAND gate right there, and that transistor NAND gate is it's interesting. It looks like it's flashing, but it's not flashing in my eyes, just on the camera. But anyway, that NAND gate sends a low pulse to these shift registers up here to the load, the parallel load, and it loads that bit value into it. And currently that bit value just has 2 bits for a green, and we get green. So in any case, it works fairly well if I just synchronize the clocks, but if I keep messing with it and unplugging the clock, periodically plugging it back in. So the next step is to find a way to get this to change on its own, and then ANDing it with whatever input signal, like from this audio responsive module that I made before, in a previous video with the microphone and the LM386. So stay tuned, more to come.